Okay, this is a quadratic application. It says an object is thrown in the air. The height of the projectile is modeled by the equation y equals -2x squared plus 38x plus 10, where x is the time in seconds and y is the height. So it's such the graph of the function, label the x-axis, vertex, x-intercept, and y-intercept. So we know that this is x and this is in time, so this is seconds. And then y is going to be my height in feet. Okay, so we're going to put this into the calculator first. And when you hit zoom 6, it does not give you a very clear picture. All right, so you have to adjust the window. The first thing I suggest is to do zoom and scroll down, do zoom fit, which is 0. So you're going to zoom fit. So that gives you a way better picture of this graph, but in these particular scenarios, we just want to look at the positive here. So I'm going to click on Window, and I only want to see positive x values because time doesn't exist. There's no negative time. So we're going to go to Window, and I'm going to adjust the window to be from 0 to, let's say, 20. And that's just a guess, 0 to 20. And then hit graph. And now we can see a much better picture of our parabola. And remember, we want to see where it starts, the vertex, and then where it hits the x-axis. So zoom fit first, and then you're going to need to adjust your x values of your window, because in this particular instance, we're talking about x is in seconds, and there's no negative time. All right, so it says sketch this. So we know here that it's going to start at 10 feet off the ground, and then it's going to go up and then back down. And then it says label the x and the y intercepts. So the y intercept, if you didn't know how I got that y intercept, you can go to second calc and do value and the value of x. So to find the y-intercept, you do second, trace, value, x equals 0. And that will tell you that right here is my y-intercept, so that's at 0, 10. Also wants to know the x-intercept. So our x-intercept is second, trace, 0. All right, and then you're going to go over to where you think the x-intercept is. And take a second to get over there. Okay, once you get over there, you're going to go left, 1, 2, 3, enter, and then back, and then right, 1, 2, 3, enter, and enter one more time. So our x-intercept is at about 19.26, comma 0. And then it also says the vertex. Now in this case, this is a maximum, so second trace again, and this is maximum. And then you want to go up to where the vertex is. About where the vertex is, and you're going to go left, 1, 2, 3, press enter, go about where the vertex is again, and then go right, 1, 2, 3, enter twice, and it tells you that the vertex is at 9.5, comma 190.5. Okay, once you have that information, then you'll be able to answer hopefully all the questions. So that's a good place to start. So vertex, remember, is second, trace, max or min. All right, let's read the first question. How long has the projectile traveled when it reaches the maximum height? So the maximum height is here. Remember that our x is in seconds, so it wants to know the travel, how long, which is time. So the time that it traveled when it reaches the maximum height is 9.5 seconds. What is the maximum height? We just talked about that maximum height was that vertex right there, so that 190.5 feet. Was the projectile launched from ground level? Okay, well, if right here this is times 0 and it automatically was at 10 feet, then no, it was launched at height of 10 feet. Because this is the time that it started. Okay, what is the height of the projectile after 2 seconds? Okay, so the height after 2 seconds. So they're telling me x equals 2. So I can go back to my calculator. Second trace value, because that's where my x equals 2, enter. So it was at 78 feet. Okay, for how long does the projectile travel before it hits the ground? Well, it hits the ground, okay, over here, because we're looking at the height. Okay, there's no height here, so it took 19.26 seconds to hit the ground. And after how many seconds is the projectile 100 feet from the ground? So 100 feet from the ground. So y equals 100. And we know if we know y equals, we can go back into y equals, arrow down once, and I'm going to put 100 here. And then we'll go back to our graph. And then this particular question says on the descent. So if you think about that, this is over time, it's traveling, it's ascending. Ascending means going up here, so we don't want to look at that intersection. It reaches its maximum height and then starts to go down, which is descent. So I want to look at this intersection right here. So second trace, intersect. Remember, you want to move over to that intersection. Enter, enter, enter. So that would be 16.22 seconds. All right, let's look at the last question. Is catapulted into the air so that its height h in meters after t seconds is h equals negative 4.9 t squared plus 27t plus 2.4. How high is the balloon after 1 second? Okay, so this is very similar to the other problem. So my suggestion is to put this into the calculator and go ahead and sketch out what it's going to look like. Okay, so I have height, which is my y, and this is in meters. And I have x, which again is in seconds. Go ahead and put that into y equals. Okay, I went ahead and put in the formula that it gave me. Okay, and then we're going to do zoom 6. Right. Notice that again, it's very difficult to see. So we're going to do zoom fit. This is still a little unclear here. So to get a better picture, remember that we're talking about distance and we're talking about time. So distance isn't negative and time isn't negative. So you can manually adjust the window by going into window. So I'm going to go 0 because I know that time is not negative. This is my x values. Then we go down here and I know that for y, distance isn't negative. So I'm going to put 0 and now I'm going to go back to graph. And that gives me a very nice picture. All right. So for this particular one, I have a graph that looks kind of like this. And remember, it's not going to go negative, so it's going to kind of stop there. All right, so let's, the first thing it wants to know, how high is the balloon after 1 second? All right, so after 1 second. So I want 1 second is about here, and it wants to know how high the balloon is. So after 1 second, that's x equals 1. So the calculator will tell me that by second trace. Value, x equals 1. So it is 24.5 meters. All right, next question. How long is the balloon more than 30 meters high? How long is the balloon more than 30 meters high? Okay, so it tells me that 30 meters high means y equals 30. Okay, so y equals 30, okay, is, let's say, somewhere here. Well, if y equals 30 here, anything above this is when that balloon is higher than 30. So the time between this intersection and this intersection is going to tell you the time it's above 30 meters. So if we go in and say y equals 30 in our second line, and then we go to graph. Okay, so again, anything above here, the height of the balloon is more than 30. So I need to know how much time that is between those two intersections. So we're going to do my intersection twice. So second calc intersection. And remember, you got to move over to the intersection. Enter 3 times. So at 1.35584 seconds, it's at 30. So remember, I want to know how long, so how many seconds, so I'm only looking for my y values. So at 1.36 seconds, and then let's do my other intersection. Okay, enter. And then 4.15 seconds. Okay, so between 1.36 seconds and 4.5 seconds, the balloon is above 30. So between. All right, let's look at the next one. The maximum height of the balloon. So the maximum height of the balloon is going to be this point right here, which is the maximum, which is our vertex. Okay, so we can go into the calc table, maximum. All right, go to where the vertex is, go left 3 times, enter. Go back to the vertex, right 3 times, enter. And then guess, press enter one more time. So the maximum height, okay, remember x is seconds, so at 2.755 seconds, the maximum height the ball reaches is balloon, 39.6 meters. And then the last one is, when will the ball burst as it hits the ground? Okay, so we know that this represents the height, so at height, over here would be height 0, so it's going to hit back at the ground. So I want to know how many seconds this is. Well, you can see that that is the x-intercept. And I know that the calculator will let me know that as well. So second calc, 0 is for x-intercept. And then I'm going to go over to where my x-intercept is. Oh, not too far. Enter. Left 3 times, and then right 3 times, enter, guess, enter one more time. So x, the time it takes is 5.6 seconds for it to be with no height, which means it hit the ground and it burst. And that is it.